Hi, in this video tutorial we'll be taking a look at factorizing, expanding and solving polynomials for the higher tier for the GCSE 9 to 1 maths, okay, and it's for the AQA, OCR and the Pearson EdExcel and WJEC EdQuest examples. Okay, so all these questions are from previous past papers and or specimen papers as well. Okay, so they are from the previous past papers. Right guys, this is question number 1. Factorize the following expressions. Part A, 6x squared plus 8x. Now this is a single bracket because I've got two terms here. Okay, so the highest common factor of 6 and 8 is 2, okay, and the highest common factor of x squared and x is equal to x. So it's 2x brackets 3x plus 4, okay, and I can always check my answer by expanding it, okay. 2x times 3x is 6x squared, and 2x times positive 4 is positive 8x. So that is the fully factorized, okay, version. Okay, and the reason it is worth 2 more of 6x squared and numbers is 2, and x is just x. Part B, factorize x squared minus 100. Now this one's a special type of example, okay, so it's a difference of 2 squares, so it's going to be a double bracket, okay. So difference of 2 squares just means that it's going to be x plus the square root of 100, which is 10. So x plus 10 times x minus 10. Oops. Okay, and I can check that by expanding that double bracket. I have x squared minus 10x plus 10x minus 100. Minus 10x plus 10x just cancel, and I get left with just 0x. So I get left with x squared minus 100. Okay, so this example is called the difference of 2 squares. So it's factorizing quadratics, where it's the difference of 2 squares, where it's x squared minus a squared, which is in the form of x plus a times x minus a, where a is a number. Part B, express x squared plus 12x plus 14 in the form x plus a all squared plus b, where a and b are whole numbers to be found. So it's completing the square, guys. So it's x plus half of the coefficient of x, so half of 12 is 6, so x plus 6 all squared, subtract 6 squared, so subtract 36, and then stick that plus 14 on at the end. Okay, so this will end up simplifying to x plus 6 all squared, and then on the outside of my bracket is going to be subtract 22, okay, because minus 36 add 14 is minus 22. Okay, so hopefully it's making sense so far. This is question number 3. Expand and simplify this double bracket. Well, m times m is m squared. M times positive 3 is positive 3m. 7 times m is 7m. And then positive 7 times positive 3 is plus 21. Okay, so this is what I call the FOIL method. So every single term in my first bracket is being multiplied by the corresponding terms on my other side. Okay, so m is being times by m plus 3, and 7 is being times by m plus 3. When I expand it, I get this quadratic expression. Now, collecting like terms, 3m plus 7m is 10m, so the final answer is m squared plus 10m plus 21. Okay. So it's a 2-mark question, guys. So 1 mark is awarded for expanding it, another mark is awarded for collecting your like terms. Okay, so it's always the like common letters, okay, that I can collect. Okay, next question. This is question number 4. Factorize fully this quadratic expression, 20x squared minus 5. Well, the highest common factor is 5 brackets 4x squared minus 1 Now we should recognize, and it is a bit tricky, guys, actually, yeah. So 4x squared minus 1 is actually the difference of 2 squares. So it's going to be 5, and then it's going to be a double bracket here. So 4x squared minus 1 factorizes to 2x plus 1 times 2x minus 1. Okay, and that's not always immediately obvious, okay, but the difference of 2 squares has to be some number, okay, so x squared minus a number, okay, or a number in front of the x squared minus a number, okay, but the idea is that it's got to have a square root of each term, okay, so for part B, the square root of 100 is 10. Okay, so that's where the plus and minus 10 came from. And x squared, the square root of x squared is just x. So that's why I've got an x and an x here. So the square root of 4x squared actually gives me 2x. So 2x and 2x. Okay, remove that squared there, sorry. Minus 1 is made by doing positive 1 times negative 1. Okay, and that's the fully factorized version. Okay, so again, it's worth 2 marks. 1 mark for getting it in this component form. The second mark is recognizing that 4x squared minus 1 is the difference of 2 squares. Okay, so hopefully it makes sense. This is question number 5. Circle the equation with roots 4 and negative 8. Well, if the roots are 4 and negative 8, so x equals 4 is my root and x equals negative 8. Okay, now one way that I can do this is I can just do like trial and error here and see which one, when I solve it, do I get this answer. Or the other way I can do is say, okay, well, if x equals 4 is a root and x equals minus 8 is another root, if I rearrange it, so if I subtract 4 on both sides for this first equation, I'm going to have x minus 4 is equal to 0. And then if I add 8 to both sides on this equation, I'm going to get x plus 8 is equal to 0. And this is actually the factorized version, okay? So that's going to be option number 2. Okay, so I'm going to circle that one there. So it's x minus 4 times x plus 8 equals 0. Because if I was to solve that, I'd get x equals 4 here and x equals negative 8, okay? This is question number 6. Factorize y squared plus 7y plus 6. Okay, so factorizing, so it's going to be a double bracket here. Okay, so y and y will go in my first and second bracket. Okay, I'm now going to work out 2 numbers that add to give me positive 7 and multiply to give me positive 6. So this is worked out by finding the factors of this end number. So the factors of 6 are 1 and 6 and 2 and 3. Okay, so 7 is made by 1 plus 6 and 6 is made by doing 1 times 6. Okay, so it's y plus 1 and y plus 6. It doesn't matter which way around I put the numbers as long as my signs are consistent in both. Okay, so what I mean by that is here it can be y plus 6 times y plus 1. Either way, it's going to be fine. Okay, let's just delete this, guys. Yes, so we got looks a bit more presentable. Okay, let's just draw like another bracket here. Okay, this is question number 7. 2x squared minus 6x plus 5 can be written in the form a brackets x minus b all squared plus c, where a, b and c are positive numbers. Work out the values of a, b and c. Okay, so it's completing the square here. So taking the 2 out as a factor, I'm going to have x squared minus 3x. So I'm only going to factor out the 2 in the first 2 terms and keep this plus 5 on the outside. Okay, I'm now going to complete the square on this part here. Okay, so I'm going to have 2 brackets and then another bracket, so it's still double brackets. X minus half of the coefficient of x, so x minus 3 over 2. Okay, all squared minus 9 quarters, okay, so minus the square of 3 over 2. Okay, close that bracket there, and then plus 5. Okay, so hopefully it's making sense so far. I'm now going to expand this bracket actually. Okay, so I get 2 lots of this, which is going to be 2 brackets x minus 3 over 2 all squared, and then I'm going to have 2 times minus 9 quarters, which is going to be minus 18 quarters or minus 9 halves. Minus 9 halves plus 5, and then I can just tidy up this bit here to make it a bit more neater. I'm going to have 2 lots of x minus 3 halves all squared, and then I'm going to have minus 9 halves plus 5, which is actually equal to plus a half, because minus 9 halves, remember, is the same as minus 4.5. Minus 4.5 plus 5 gives me positive 0.5, or just plus a half. So the answers are, so the value of A is 2, the value of B is 3 halves, sorry, and the value of C is equal to 1 half. Okay, so that would be my answer for that question. Okay, part B, using an answer to part A or otherwise, solve this equation. Okay, so solving this is equal to 8.5. Well, instead of writing this here, I'm going to write 2 brackets x minus 3 halves all squared plus a half, and that has to be equal to 8.5. Okay, so the first step here, guys, okay, is I'm going to subtract a half on both sides. Okay, so I want to try and solve for x. Okay, so I'm going to get 2 lots of x minus 3 halves all squared should be a 2 there. Okay, is equal to 8.5 minus half is just going to be 8. I'm now going to divide both sides by 2, so let's just put it here so we got a bit more space. Or I might put it on the bottom actually, so we got a bit more space on the bottom, and then I'll rub it off. So let's just put a little star there. So dividing everything by 2, I'm going to get x minus 3 halves all squared is equal to 8 divided by 2, which is equal to 4. Taking the square root of both sides, I get x minus 3 halves. Okay, hopefully it's making sense so far, guys, yeah, and you're still with me, equals plus and minus the root of 4, which is going to be equal to 2. And then adding 3 halves to both sides will give me my x solution to be x is equal to 3 halves plus and minus the square root of 4, which is equal to plus and minus 2. Okay, so plus and minus 2, Okay, so my final solutions are that x could equal 3/2 plus 2, which is going to be equal to 7/2, or x could equal 3/2 minus 2, which is equal to -1/2. And they would be my solutions for part B. Okay, so because it was written in completed square form, it was just the idea of rearranging to make x the subject for that question. Okay, so x equals -1/2, or x equals positive 7/2. Okay, so I hope that actually makes sense so far, guys. Sorry, yeah, if there wasn't actually much space there actually, but in the exam, it is important that the examiners will always give you plenty of space. Okay, but in these worksheets, I think, yeah, these spaces are a bit trickier to work out our answer. This is question number 8, part A. Find the interval for which x squared minus 7x plus 10 is less than or equal to 0. Okay, so working this out, guys, so factorizing this, so it's a quadratic inequality. I'm going to have x minus 2 and x minus 5 is less than or equal to 0. So this is solving a quadratic inequality. So let's just do like a rough sketch. Okay, so the solutions are 2 and 5, okay? So we want it for when this graph is less than 0, so it's this interval here. So it's greater than 2 and less than 5. Okay, so it's greater than or equal to 2 and less than or equal to 5. Okay, this is part B. Okay, the point -3 minus 4 is the turning point on the graph y equals x squared plus ax plus b, where a and b are integers. Find the values of a and b. So if that's the turning point, that's what I call my minimum point. Okay, so -3, 4 is going to be somewhere here, okay, roughly. So the graph's going to either turn like this, okay, because it is a turning point, okay. Now looking at our values of x and y, we're going to have that y is equal to x plus 3 all squared, because it is a quadratic, okay, minus 4, okay, because if I was to use this and work backwards, the equation of my minimum point, or the coordinates of my minimum point, would be -3 minus 4, which is what this graph is actually representing. So expanding all this out, I'm going to get x squared plus 6x plus 9, and then subtract the 4, I'm going to get 5. So I'm going to get x squared. So y is equal to x squared plus 6x plus 5. Okay. And if I was to complete the square on this quadratic, it would give me the minimum as -3 minus 4. So a is equal to 6 and b is equal to positive 5. Okay, so I hope that makes sense so far, guys. Again, any questions, any queries, then make sure that you put it in the comment section. So let's just delete this now so we can answer question number 9. Or 6, sorry. I'm not sure why there is a 6 there. It should be a 9, sorry. Okay, so this is question number 9. Okay, so we are given that y is equal to 6x to the 4 plus 7x squared. Okay, and x is equal to square root of w plus 1. Find the value of w when y is equal to 10. So let's just sub in y is 10 interior sheet and rearrange it. I'm going to have 6x to the 4 plus 7x squared. Subtract that 10, and that's going to be equal to 0. Okay, so it's looking like a pretty nasty quartic equation here, but we'll obviously break it down here and obviously work out our answer. So what I'm going to try and attempt now, guys, is actually factorize this. So let's see if it factorizes into a bracket. I think it should actually factorize, otherwise it's a pretty nasty question, I feel. X plus, okay, we're going to make 7 and then we're going to make minus 10. So if we pick the factors 2 and 5, let's see what we get. If I put 2 there, I'm going to get positive 12 minus 5 is equal to 7. Okay, brilliant. Right, so factorizing it, I'm going to get that. So it's going to be 6x squared, and then I'm going to have an x squared there. Okay, because it is a power of 4 there. 6x squared times x squared is 6x to the 4, plus 12x squared minus 5x squared is going to be plus 7x squared, and then minus 5 times positive 2 is equal to minus 10. Now straight away this can be disregarded because I can't solve x squared plus 2 equals 0 normally, so this has no real roots for this one. So I'm going to be solving this equation here. So I'm going to have x squared is equal to 5/6, x is equal to plus and minus 5/6. Okay, so that's my solution when I solve this quadratic equal to 0. So adding 5 to both sides, I get 6x squared equals 5, divided by 6 equals x squared equals 5/6. X equals plus and minus the square root of 5/6. Okay. So let's just delete this actually. So I've got a bit more space here. Okay, so hopefully it's making sense so far. Okay, and if it isn't, then obviously please do ask me during like the live chat here or during the comments below. Okay. So now I can sub this in to work out what the value of W is, because W equals, so if I do x squared plus 1, that's going to give me the value for W, okay, by rearranging that formula. So squaring both sides and then minusing 1, sorry, not adding 1. So x squared minus 1, okay, is equal to W. So x is equal to plus or minus the square root of it. So if I square that, I'm going to get 5/6 minus 1 is going to give me the value for W, okay? Because if I square this, I'm subbing x equal to plus or minus root 5/6 into this x squared minus 1 equals W. It's going to give me the value for W. So W is going to be equal to 5/6 minus 1, which is equal to minus 1/6, okay? Because 1 can be written as 6/6, okay? So I can change that 1 into 6 out of 6. Okay, and then when I minus my fraction, same bottom numbers, just minus the top. 5 take away 6 is minus 1. So W is equal to minus a 6th. Okay, following y is equal to 10. So that was a pretty demanding question, yeah, and it was worth a 6-mark question. Okay, that's something that would probably appear more on like an A level, but never say never. So it could also appear like a higher tier. Okay, but it's something that would appear probably more so on like an AS or A2 pure maths paper, yeah, for A level maths. Okay, or even A level further maths. Right, guys, this is question number 7. So factorize this quadratic expression. Okay, so double brackets, guys. Okay, so this time I've got a number in front of the x squared. I'm going to have 3x, and then I'm going to have x. I'm going to have a plus and a plus here because it's both pluses. It's two numbers that add to give me positive 14x, or 14, sorry, and multiply to give me positive 8. Well, testing my numbers, I'm going to have 1 and 8 and 2 and 4. Okay, so let's just test it. Put in 4 there and put in 2 there. I get 3x squared plus 12x plus 2x gives me positive 14x. And then 2 times 4 is equal to 8. Okay, so that's my answer for that one. Right, guys, okay, this is question number 11a. So express this quadratic expression in the completed square form. So it's x plus half of the coefficient of x, so it's half the number in front of the x, half 10 is 5, all squared, subtract 5 squared, so minus 25 plus 29. So tidying that up, okay, I'm going to have the answer to be x plus 5 all squared minus 25 plus 29 is positive 4. Okay. This is part B. Write down the coordinate of the turning point on the graph y equals x squared plus 10x plus 29. We're looking at part A, so write x squared plus 10x plus 29 in the form x plus 8 all squared plus b. So completed square form allows us to work out the minimum point. So it's the opposite sign here for the x value. So it's going to be minus 5 and it's going to be positive 4. Okay, so the coordinates are minus 5, 4. Okay, for the turning points. So turning points just means the point at which the graph changes its gradient, essentially. So it's changing its gradient at that point. Okay, so it would look something like that. Okay, possibly. Okay. Or it can also look like that for like a maximum, okay, depending on which sort of coordinates I'm looking at. Okay. Obviously, this one would be like a negative here, like quadratic here for that one. Okay, this is question number 12a. Expand and simplify. X times x is x squared. X times positive 2 is positive 2x. 7 times x is 7x. And 7 times positive 2 is positive 14. Okay, so it's always expanding everything in my bracket plus 14. So collecting like terms, 2x plus 7x is 9x. So it's x squared plus 9x plus 14. And that will be my final answer. Okay, this is part B. Factorize completely this. Okay, so this is actually a single bracket. So the highest common factor between 2x squared and minus 6xy is going to be 2x. Open brackets, x minus 3y. Okay, and we can check our answer by expanding that single bracket. 2x times x is 2x squared, and 2x times negative 3y is negative 6y. Okay, sorry, negative 6xy, sorry. Okay. Part C, solve this quadratic equation. So first step is that I'm going to minus 24 on both sides. So I get it equal to 0. And then I can factorize it. So I get x squared plus 5x minus 24 is equal to 0. Okay, so factorizing this into a double bracket because it is a quadratic, and then we're going to obviously solve it by working out our x values. Okay, x and x go there. It's going to be a plus and a minus because I've got a negative 24 there. Okay, so the factors of 24 are 1 and 24, 2 and 12, 3 and 8. Okay, 4 and 6, and they are my factors of 24. So it's going to be positive 8 and minus 3. Okay, so solving this equation, I get that x is equal to negative 8 by solving the first equation, and solving the second equation, I get that x is equal to positive 3. So x equals 8 and or x equals 3. Okay, this is question number 13. Factorize this quadratic expression. It's going to be double brackets, okay? X and x go there. It's going to be a plus and a minus because I've got a minus 4 at the end. So a positive times a negative gives me a negative. It's x plus 4 times x minus 1. Okay, so it's two numbers that add to give me positive 3x and multiply to give me negative 4. Well, the factors of 4 are 1 and 4 and 2 and 2. I can't make 3 with 2 and 2, so my options are 1 and 4. So it's going to be positive 4 and minus 1. Okay, question number 14. Factorize this, y squared plus 27y. We're taking out y as a factor. Y plus 27. Okay, because y is the highest common factor of both y squared and 27y. This is question number 15. Expand and simplify this double bracket. So y times y is y squared. Y times negative 4 is negative 4y. 5 times y is positive 5y. And then 5 times negative 4 is negative 20. Okay, so the last part is just collecting like terms. So my final answer is y squared plus y or plus 1y minus 20. Okay. This is question number 16. X brackets x plus 4 is equivalent to x squared plus 4x plus 4. For how many values of x is x brackets x plus 4 equal to x squared plus 4x? Circle your answer. Well, equivalent here means that it's true for all values of x. Okay, this is question number 17. Factorize fully this. Okay, so the highest common factor between 9a squared and 6a is going to be 3a. So 3a brackets 3a minus 2. Okay, close the brackets. And then I can check my answer by expanding. 3a times 3a is 9a squared. 3a times negative 2 is minus 6a. Question number 18. So write x squared plus 2x minus 8 in the form x plus m all squared plus n, where m and n are integers. So it's completing the square again. So half the coefficient in front of the x plus 1, half of 2 is 1. Okay. Squared minus 1 minus 8, which I can just tidy that up to be x plus 1 all squared minus 9. Okay, that's my answer for that one. Question number 19a. Write this quadratic expression in completed square form, okay, where a, b, and c are integers. So again, factorizing, so taking the 2 as a factor for the first two terms, x squared plus 8x, and then close my brackets, and then I'm going to have a plus 35 here. I'm now going to complete the square on the bit inside the bracket. So I'm going to open up another bracket here. So x plus half of 8x is going to be 4 all squared minus 4 squared, which is 16. Close that bracket. Oops. So close that bracket there. And then add the 35. Once I've closed it, okay, I'm now going to expand this bracket here. So 2 lots of this is going to be 2 brackets x plus 4 all squared. 2 times negative 16 is minus 32. Minus 32, and then I can add the 35. Okay, so I'm going to have 2 brackets x plus 4 all squared minus 32 plus 35 simplifies to just a positive 3. Okay, for part B, hence or otherwise, write down the coordinates of the turning point of the graph y equals 2x squared plus 16x plus 35. Well, it's going to be minus 4 and positive 3. Okay, so it's the opposite sign for the x value and it's the same sign for the y value. This is question number 20, so it's the last question for today's video, guys. Solve this quadratic equation. Write your answer in the form a plus minus square root of b, where a and b are integers. So solving x squared minus 6x minus 8 equals 0. I'm going to complete the square root actually to make it a bit easier. So x minus 3 all squared minus 9 minus 8 is equal to 0. Rearranging, so getting this onto the right hand side, I'm going to have x minus 3 all squared is equal to 17. Taking the square root of both sides, I get x minus 3 is equal to plus and minus the square root of 17. Adding 3 to both sides, we get that x is equal to 3 plus and minus the square root of 17. Okay, and that's my solution or solutions to the quadratic equation. It's a plus and a minus there because a quadratic always has two distinct real roots where possible or where appropriate. Okay, so the plus and minus there because when I take the square root of something, okay, the opposite of squaring something is square root. So if I have x squared equals a number, x is always equal to plus and minus the square root of that number, provided that number is obviously real. Okay. Right guys, so that takes us to the end of today's video. So I hope you found it useful. Okay, I hope you found it informative. If you did, please press like, please subscribe to the channel if you're new, and lastly, please press that bell icon so turn on post notification so you don't miss out on further videos and further uploads on my channel for Key Stage 3 Maths, GCSE Maths, A-Level Pure Maths and A-Level Further Pure Maths, okay, and a bit of Key Stage 2 Maths as well. Okay, but that's it for me today, guys. Thank you so much for watching. My name is Abdallah W, and I run the Abdallah Maths Tutoring 2021 channel, and I'm also your online GCSE Maths tutor for higher and foundation, and also for Key Stage 3, and also for A-Level Maths and A-Level Further Maths. Okay, but that's it for me today, guys. Thank you so much for watching. Take care, stay safe, enjoy your Christmas break, and I'll catch you the next one. Okay, Merry Christmas, and I'll see you soon.